Hello, students. So we have started our new. It's not new. It's on our word problems, but here we are working with geometry problems. So let's start. Number one. So you'll have to. Once you have a geometry, it's always good to have your key furnished in the visualization. If you don't have visual, then go for visual. So what they say, the length of a rectangle. So what a rectangle is? Let's draw a rectangle. It's helpful for you. So where is a rectangle? So the length. So now let's name them. Traditional practice is to do the longer side as length. You can take any of the side. Of a rectangle is 2 less. This guy is 2 less, right? Then twice the width. So that's width. Now who is the width of this rectangle? This one, because we know a rectangle has length and width. So now if the perimeter. So before we go, let's fix our variables. Our traditional practice is to we say let. If you write, what do you write? Let x be the width of the rectangle. So we say this. Now what will happen? Therefore, the length is going to be, in place of width is x, so 2x minus 2. So we can say 2x minus 2 is the length of this rectangle. So once they tell us the perimeter of the rectangle, of this rectangle, is 92 feet. Close the door. 92 feet. So perimeter. So what is the perimeter of a rectangle? We know that a perimeter is the continuous boundary line of any closed figure. So this is a closed figure. So boundary line, this is width. So this has to be again the width. And this is length. So the opposite is congruent, we know. So that's also going to be the length. So if we add up, we have 2 lengths and 2 width. So 2 width. So if we think that perimeter, which is given in our, now we form up our, after we fixed up our key, we form up our equation. So this is in total, perimeter is 92, and this perimeter 2 times of length we want to get in one variable, so the length itself is this. So 2 times of 2x minus 2. Be careful here. So many 2's, so somebody might forget this 2. Plus 2 times of width. What is the width? That's x. So our equation is formed up. So let's go for the solution. I'm taking some places here. So from here we can move on. 2 times of 2x gives us 4x. Positive to negative 2 gives us negative 4. And we have a positive 2x here and equals 92. So now let's go on. Solution. Like terms. So 6x. We have a negative 4 here, 92. So you got to isolate this x. So addition property of equality at 4. So we do it for that property in the right hand side too. So we have a 6x here. This positive negative cancels out and two same signs, so they add up 96. I need to isolate this x, so we divide by 6. Divide by 6. So what do we get? We get x as 6 ones are 6, 36, 6, 16. So we got our x, which is our width, right? That's our assumption was. Now the x for measures. What are the measures of the width? We got it. And the length. So where can we find length? Length is in terms of x is this, right? Which is furnished here. So we say 2x minus 2. So we say our length is 2x minus 2. You measure, right? It's always good to write so that you don't make mistakes. So 2 16s are how much? Should be 32 and minus 2. And remember, once it's geometry, dimensions are in action, you'll have to remember about the units. So 12 feet, 92 feet. So you write them. It's more than one, so 16 feet. Okay. And 30 feet. Let me put them in one box since they're the answers, right? So 30 feet. Now your job is to write the answers. So you say the length, the length, the length of the rectangle is 30 feet, and you can shorten it with these 16, right? 16. That's it. That's the perfect example of following the Casca and writing, and it will be expected in the school, and you'll have to demonstrate it. So this comes up step by step. Since I have done it here, so I have written in several places. So you see, this is your problem. Okay, let me clear them. And you have labeled them, and then you have visualized them, you have labeled them, and you got it. That's the process. Now many of you might do it without drawing, by imagination. That's good. So this is the complete presentation that I wanted to do, how your thinking process will do. That's a complete way. We'll go on and solve these problems too in the classroom, and I'll make more videos. Thank you very much. This is just one demonstration for Casca with the geometry problem.